In question 2, we have a table of de Broglie wavelength for an electron with its velocity v. In 2.1, we're to show that the data is consistent with the relationship lambda is directly proportional to 1 over v. Well, if wavelength is proportional to 1 over v, it means that the wavelength is equal to a constant over v, which means that lambda times speed is equal to a constant. We can try this for the 3 lots of data. 1.5 times 4.9 gives 7.35. 2.5 times 2.9, that should be 0.9, gives 7.25, and 3.5 times 2.1 gives 7.35. These are so close as to be a constant, and therefore the relationship is correct. In 2.2, we're to calculate a value for the Planck constant suggested by the data. Well, the de Broglie wavelength is given by the Planck constant over the momentum, and that is the Planck constant over mv. So basically we can say that the Planck constant is equal to the wavelength times the mass times the speed. We can work out the mean lambda v from our previous data, which is 7.35 plus 7.25 plus 7.35 over 3, but then we also need to multiply it by 10 to the 7 to get the speed correct in meters per second, and by 10 to the minus 11 to get the wavelength correct. And this gives a mean lambda v of 7.32 times 10 to the minus 4. So then we can give our Planck constant as being, so h is 7.32 times 10 to the minus 4 multiplied by the mass of the electron, 9.11 times 10 to the minus 31, which gives an answer of 6.67 times 10 to the minus 34 joule seconds. As our data is only to 2 significant figures, in the table we'd need to write this as 6.7 times 10 to the minus 34 joule seconds. In 2.3, we're asked to explain how the pattern supports the idea that the electron beam is behaving as a wave rather than as a stream of particles. Well, the electrons are being diffracted and spread out as they pass between the atoms and the graphite. This is a wave effect. They then meet in phase and constructively interfere at the bright rings, and they meet in antiphase, destructively interfering at the dark rings. In 2.4, we're to explain how the emission of light from the screen shows the electrons are behaving as particles. Well, they provide kinetic energy to excite electrons in the screen. This is a one-to-one interaction, not a gradual transfer of energy as it would be for a wave. The accelerated electrons are colliding with electrons within energy levels of the atoms of the screen. They excite them to higher energy levels. They emit light as they relax back to lower energy levels.